Hello everyone. In today's class, we are going to start with chapter number 13, limits and derivatives. Limit of a function. Consider a function f of x which is given by x square minus 1 divided by x minus 1. Now, for any value of x, let me consider say x is equal to 2. When x is equal to 2, I can tell that the value of the function f of x is going to be 2 square minus 1 divided by 2 minus 1, which is going to be 4 minus 1 divided by 1. The answer is going to be. Similarly, I can take the value of x is equal to 2, 3, 4, any value. So f of x now is going to be equal to, substitute the value of 3 in place of x, 3 square minus 1 divided by 3 minus 1. In this case, it is going to be 9 minus 1 divided by 2, 8 divided by 2. The answer is 4, right? So whenever I'm taking the value of x and I'm substituting, I'm getting some or the other value for f of x, which is the function of x. Now, similar to this, what will happen when I substitute x is equal to 1? When I substitute x is equal to 1, f of x is going to be 1 square minus 1 over 1 minus 1, 0 over 0. So here I am getting 0 over 0. This is known as indeterminate. Indeterminate. Meaning we cannot find the value of 0 over 0. So what I am going to do is, I cannot find what is the value of f of x when x is equal to 1. Exactly when x is equal to 1. So what I am going to do is, I am going to take all the values of x which are close to 1 but not exactly 1. X I have taken as 1.1, 1.001, 1.00001, zero point 0.9, 0.99, 0.9999, and so on. Basically, I have considered few numbers which are not equal to 1 but they are nearing to 1. When I substitute the same thing, I will be getting the value of f of x as 2.1, 2.001, 2.0001, 1.9, 1.99, 1.9999, and so on. Right? Here we make an observation. What is that? In the function f of x, which is x square minus 1, we observe that the value of f of x takes close to 2. The value goes equal to 2 or close to 2 when I have considered, or when x approaches the value close to 1. That is, f of x approaches to 2 as x approaches to 1. So whenever I take the value of x which is nearing to 1, the value of f of x is going to be nearing to 2, right? This can be mathematically restated as limit of f of x as x approaches 1 or as x tends to 1 is 2. So generally I can write limit of function f of x as x tends to small a is going to be equal to capital A, right? For this particular function, I can write the same thing. So I can write limit of the value of x as it tends to 1. What is going to happen to the value of f of x? It is going to be equal to 2. So this is the way I can represent, okay? And this is read as limit of the function f of x as x tends to 1 is equal to 2. This is for this particular question. Generally, I can write like this. All right. Now, we have different methods in which we can compute our limits: direct substitution, factorization, rationalization, and using standard limits. In this class, we are going to restrict ourselves to 1 and 2, that is direct substitution and factorization. The first one I'm going to consider is direct substitution. When are you going to use this method? You can use this method whenever you are not getting 0 over 0 or infinity as your last answer. If you get your answer as a particular number or a constant, then you can use direct substitution. So let me take few examples, or rather exercise questions based on direct substitution. This is the first method. All right, we have four methods. We are going to discuss one by one. The first question is limit of x plus 3 as x tends to 3. So I can write here, I will rewrite the question. Limit of x plus 3 we have to find as x tends to 3. So I can write this as, when x is equal to 3, what is the value of x plus 3? That is the thing I have to do here. So x plus 3, I can write it as 3 plus 3, which is going to be equal to 6. So I can write here limit of x plus 3 as x tends to 3 is going to be equal to 6. This is your solution. The second one, limit of x minus 22 by 7 as x tends to pi. So I can write here limit of x minus 22 over 7 as x tends to pi is going to be, substitute pi in the value of x, pi minus 22 over 7. This is going to be your answer. Similarly, fourth one, limit of 4x plus 3 divided by x minus 2. So I will be writing limit of x tending to 4, 4 plus 3 and x minus 2. This is going to be equal to, substituting the value of 4 in place of x, 4 multiplied by 4 plus 3 divided by 4 minus 2. So I can write limit of 4x plus 3 over x minus 2 as x tends to 4 is going to be 4 multiplied by 4, which is going to be 16, plus 3 divided by 2. It is going to be 19 divided by 2, not 3, is going to be 2. 19 divided by 2. This is going to be your answer. Let us move to the next question. These are all simple. Direct substitution is very, very simple. The fifth one, limit of x to the power 10 plus x to the power 5 plus 1 over x minus 1. So I can write limit of the function as x tends to minus 1 is going to be x to the power 10 plus x to the power 5 plus 1 over x minus 1. I will be getting the value as minus 1 raised to the power 10 plus minus 1 raised to the power 5 plus 1 divided by minus 1 minus 1. So I will be getting the answer as minus 1 raised to the power of even number is going to be a positive 1, plus 1, minus 1 raised to the power odd number is minus 1 plus 1 divided by minus 2. So the answer is going to be 1 over minus 2. I can write it as minus 1 over 2. This is going to be the answer for the fifth one. Let me take one more problem based on direct substitution. Limit of ax plus b divided by cx plus 1. So I can write limit of extending to 0 of the function ax plus b divided by cx plus 1 is going to be, substitute the value of x as 0, a multiplied by 0 plus b divided by c multiplied by 0 plus 1. So I can write that the limit of x tending to 0 of ax plus b divided by cx plus b is going to be this, and this is going to be 0. I can write just as b divided by 1, which I can take as b itself. Or let me write here b divided by 1. All right. Now, similarly, last question I'm taking of direct substitution. Then we will move on to the next method. 11th question, find the value of ax square plus bx plus c divided by cx square plus bx plus a as x tends to 1. I'm going to solve this directly. So just in the place of x, you need to substitute the value of 1. So a 1 square plus b into 1 plus c divided by c into 1 square plus b into 1 plus a. So the answer is going to be a plus b plus c divided by, here it is going to be c plus b plus a. Since addition is commutative, a plus b plus c is a plus c plus a, the order does not matter. Answer is going to be 1, right? This was solving or computation of limit using the direct substitution method. We have just taken the value of x, we are substituting and we are getting the answer, right? Now, let us go to the second method, which is factorization method. To illustrate this, let me take the example which I had taken in the beginning of the class. So here I have taken, consider a function f of x, x minus 1 over x minus 1. Let me take the same thing. Somebody is here. Let me just check. I think it's Aditya. Now, let me take the question which I had taken at the beginning of the class. So f of x, right, is equal to x square minus 1 divided by x minus 1. Now, if I take the limit, okay, if I take the limit of the function f of x, which is x square minus 1 divided by x minus 1 as x tends to 1, let us see what is going to happen. So it is going to be 1 square minus 1 divided by 1 minus 1. The answer is going to be 0 over 0. Now this is indeterminate. You cannot find the value, right? But what is the value I have got in from the table? From the table have I got that f of x, I am getting value nearing to 2, right? When I take the value of x nearing to 1, I should be getting the value of f of x as 2, right? This is what I have got. But now, how can I solve the same thing, right, when I cannot get the value over here? Now, I can do one thing. What is that? Let me rewrite the question again. So, I can write this as limit of x tending to 1, x square minus 1 over x minus 1. I observed that when I directly substitute for 1 in this equation, I am getting as 0 divided by 0, and this is indeterminate. So this is not the way to go, right? I'm going to do one thing over here. Can I write the same thing, x square minus 1 as x square minus 1 square divided by x minus 1? The value doesn't change because 1 square and 1 both are equal. Now, what is a square minus b square? I know that a square minus b square is a plus b multiplied by a minus b. So I can tell that the limit of the function as x tends to 1, let me keep it as it is. I am not applying the limit as of now. X square minus 1 over x minus 1 can be written as x square minus 1 square. Now x square minus 1 square can be written as in the form of a plus b into a minus b. Upon doing that, I will be getting x plus 1 multiplied by x minus 1 over x minus 1. This and this both are one and the same, just the form is different. Now, can I cancel x minus 1 and x minus 1? Yes, I can cancel x minus 1 with x minus 1. I will be left with the limit of x tending to 1 of x plus 1. Now, if I apply the limit, it is going to be 1 plus 1. The answer is going to be equal to 2. Is this the same thing which we have got from the table? Whenever we are taking the value of x nearing to 1, the value of f of x will be nearing to 2. This will be your factorization method. Let me take few questions from the exercise based on the same method. All right. Seventh one, limit of x tends to 2 when 3x of 3x square minus x minus 10 divided by x square minus 4. I observe that when I substitute the value of 2 here, what is going to happen? 2 square is going to be 4. 4 minus 4 is going to be 0. You cannot divide any number by 0. Then the value is going to be indeterminate, right? So what can I do here? So let me take the same question, limit of x tending to 2 of 3x square minus x minus 10 divided by x square minus 4. Now I have to rewrite the equation such that I will be getting a particular value when I substitute x is equal to 2. As of now, I cannot substitute because now if I substitute, the value will be 0, right? 0 I will be getting as a denominator. I cannot get that because then the value is going to be infinity, right? Now let me take the numerator, 3x square minus x minus 10. Now is this a quadratic equation? This is a quadratic equation, right? So I can solve the quadratic equation. Here I will be getting minus 1, here I should be getting 30. So I should be taking two numbers. When I add, I should be getting minus 1, and when I take the product, I will be getting minus 30. Those are minus 6 and plus 5. So by factorization or by splitting the middle term, 3x square minus 6x plus 5x minus 10. 3x square minus x minus 10 can be written as 3x square minus 6x plus 5 minus 10. Quadratic, we are just solving the quadratic equation. Now I can take common, 3x is common, so x minus 2 over here, x minus 2 over here, it is going to be 5. Now x minus 2 will be equal to 0, or let me take just these products. So I can write this as x minus 2 multiplied by 3x plus 5. 3x square minus x minus 10 now can be written as x minus 2 multiplied by 3x plus 5. The same thing I'm going to substitute over here. So let me take this as equation number 1, right? Next, I can consider the denominator. So this was the numerator part, right? Next, I'll be considering the denominator. Denominator, I have x square minus 4. X square minus 4, can you write the same thing as x square minus 2 square? Now this is of the form a square minus b square again. A square minus b square, which can be written as a plus b into a minus b, a plus b multiplied by a minus b. If a square minus b square can be written as a plus b into a minus b, then I can write x square minus 2 square as x minus 2 or x plus 2 multiplied by x minus 2. This can be taken as equation number 1. Substituting the values, n and d, that is numerator and denominator, from 1 and 2, I can write the limit as limit of the function as x tends to 2, 3x square minus x minus 10, now it is going to be x minus 2 multiplied by 3x plus 5 divided by x plus 2 multiplied by x minus 2. Now I can cancel x minus 2 with x minus 2. So I will be left with limit of x tending to 2, 3x plus 5 and x plus 2. So let me just take one more slide over here. So I'm left with 3x plus 5 and x plus 2. limit of 3x plus 5 and x plus. Now I just need to substitute the value of x. 3 multiplied by 2 plus 5 divided by 2 plus 2. The answer is going to be 6 plus 5 divided by 2 plus 2, which is 4. The answer is going to be 11 divided by 4. Finally, the answer can be written this way. Limit of x tending to 2, 3x square minus x minus 10 divided by x square minus 4 is going to be 11 over. This is going to be your final answer. We'll take the next question. Question number 8. Evaluate the given limit. Limit of x to the power 4 minus 81 divided by 2x square minus 5x minus 3. Now, when I substitute the value of 3, 3 to the power 4 is 81. 81 minus 81 I am going to get as 0. So, I cannot substitute the value of x directly. I need to factorize the same, right? How can you write x to the power 4 minus 81 and 2x square minus 5x plus 3 in different way, and you can factorize. We'll be considering the same thing. Let me take down the problem. Limit of x tending to 3, x to the power 4 minus 81 divided by 2x square minus 5x minus 3. Let me take the numerator and the denominator. So this is the numerator, this is the. I will solve the numerator over here first. It is x to the power 4 minus 81. Now, 81 and x to the power 4. Anyway, can you write and simplify? Do you see any other way? 3 to the power 4, sir. Yes, the same thing. X to the power 4 and 81 is nothing but 3 to the power 4. So I can write this as 3 raised to the power 4. Right? Now, 3 raised to the power 4 can be written as 3 raised to the power 2 whole raised to the power 2, because a raised to the power b raised to the power m can be written as a to the power bm. We have studied in exponents and powers. Using the same thing, x square minus 3 to the power 4 can be written as 3 square whole square. Now I can write this as x to the even x to the power 4 can be written the same way. So x raised to the power 4, I can write it as x square whole square minus 3 square whole square. Now, this is of the form a square minus b square, which can be written as a plus b into a minus. I will be getting x square whole square minus 3 square whole square as a plus b. Here a plus b is x square plus 3 square. 3 square is 9 multiplied by x square, which is a, and minus b minus 9. This you can take as equation number 1, which you will be substituting in the place of numerator, right? Still it is not in the proper form. Further, I can simplify the same. Let me do that later. As of now, let me take x, the numerator one. All right. For the numerator, sorry, for the denominator, I have a quadratic equation. I can solve this quadratic equation. Upon solving, I will be getting 2x minus 5x minus 3. So I need to find out two numbers such that when I multiply, I should be getting minus 6. When I add, I will be getting minus 5. What are those two numbers? 3 and 2 can I take? Yes, or anything else? Yes, anything else? Or we just need to factorize this. Okay, you can either use splitting the middle term or your quadratic equation also. All right, 2x square minus 5x minus 3, this can be written as 2x if I take it as common, 2x plus 1 multiplied by x is there, x minus 3. I can write this way. This can be factorized this way. Either you can use splitting the middle term or also your equation. Best is splitting the middle term, right? This you can take it as equation number 2. Now let me substitute equation number 1 and equation number 2 over here. So let me repeat again what we are doing. First, we observed that whenever we substitute directly the value of 3 in the given equation or given function, we are getting the value as 0, right? 0 over 0. This is what we will be getting. So this is indeterminate. When we have indeterminate form, we need to change the function in a way that it remains the same but it is different. For example, x square minus 1, same thing as x square minus 1 square, same thing as x square minus 1 square multiplied by 2 divided by 2, same thing, right? The value is not going to change, just the form you have to change. In order to do that, I have taken numerator and denominator separately. Numerator I have solved as x square plus 1 multiplied by x square minus 9. Denominator I have got as 2x plus 1 multiplied by x minus 3. Let me write down the same thing in the next slide and continue with the question. Yes, I have here limit of x tending to 3. In the numerator, I can write x square plus 9 multiplied by x square minus 9 divided by 2x plus 1 x minus 3. 2x plus 1 and x minus 3. Now, let me check whether I'll be getting the answers. 3, when I substitute, again, here 3 square is 9. 9 minus 9 is 0. Here 3 is there. 3 minus 3 will be 0. Again, I cannot solve, right? Further, I need to simplify these equation. In order to do that, can I write limit of x tending to 3, x square plus 9 can be written as x square plus 3 square. Yes, this is of the form a square plus b square. So I will be getting x square plus 3 square can be written as, how can you write this as? Okay, let me take it a square minus b square itself. Okay, so I have written over here 2x square minus 5x minus 3 in the denominator as x tending to 3. Here we have got 2x plus 1 and x minus 3. Here we had x square minus 9 and x square plus 9. Let me take x square minus 9 as x square minus 3 square. Now this is of the form a square minus b square, which is a plus b into a minus b. I can write x square minus 3 square as x minus 3 multiplied by x plus 3, right? Let me substitute the same thing. Limit of x tending to 3, x square minus 9 can be written as x minus 3 multiplied by x plus 3 multiplied by x square minus 9, which is here, divided by 2x plus 1 multiplied by x minus 3. Now I can cancel x minus 3 with x minus 3. Right? Getting it? I will be left with limit of x tending to 3, x plus 3, x square plus 9 divided by 2x plus 1 multiplied by, okay, this is anyway cancelled, so I need not take that. Let me substitute the value of x and I will be arriving at my answer. Substituting the value of x as 3, 3 plus 3 multiplied by 3 square plus 9 divided by 2x, which is 2 multiplied by 3 plus 1. Upon solving, I will be getting this as 6 multiplied by 3 square is 9, 9 plus 9 is 18, divided by 2 into 3 is 6, 6 plus 1. 6 multiplied by 18 is 108 and 6 plus 1 is 7. So I can finally write that the limit of x tending to 3 for the function x to the power 4 minus 81 divided by 2x square minus 5x minus 3 is going to be 108 divided by 7. This is going to be your final answer.